Okay. All right. Good morning, everyone. Thank you for joining us for our second Meet the Experts webinar here at CLISO. Today, we are featuring our fellow CTO, Dan Vanderster. He has a background with CERN and is on the executive council for the Ceph Foundation. So lots of experience in Ceph. And Dan, with that, I'll leave it to you to go into your presentation.
Thanks, Leanne. Yeah, hi everyone. Calling in from the morning here in Vancouver. So today, I'm going to talk a bit about one of my favorite subjects in Ceph, which is like how we place data in Ceph. So the presentation is called Ceph Unleashed, Upmap for Optimal Data Placement. I'll just get right to it. Just a very quick background about myself. People that don't know me, I did grad school in distributed systems, so-called grid computing here in University of Victoria in Canada. I was CERN IT staff since 2008, working on Ceph since around 2012, 2013. And currently I'm on sabbatical, like Leanne said, working here at CLISO, trying to, we're building a Ceph support company, Ceph helping Ceph people around the world, open infrastructure. And I've also been involved in the open source Ceph community for a while. I used to be a lot more noisy on the mailing list than I am today. But yeah, I've been involved in the Ceph board since it was created, and that's right, I'm on the Ceph Executive Council since 2021. So right into it, the talk. But before we get started, I just wanted to put a fun little poll out there on LinkedIn. I think you need a LinkedIn account to actually respond to this. On LinkedIn, I put a silly little poll. Just want to get people's opinion without doing any cheating or anything. Try to answer how old is Ceph. We'll come back at the end of the talk and I'll at least tell you my opinion for what the answer is. Is it 5 to 10, 10 to 15, 15 to 20, or maybe more than 20 years old? We'll see at the end. Oh yeah, and there's a tiny.cc/Ceph poll. You can kind of type that in, try to respond to it. So what's the purpose of this talk? So, back when I was a kid, I heard that quote from Arthur C. Clarke: any sufficiently advanced technology is indistinguishable from magic. That's sort of how I feel about Ceph. And when I first learned about Ceph and started using Ceph, and I think lots of us might feel the same way, Ceph is like, compared to old school storage, it's like magic. But when the magic fails, it's like, you better know the tricks behind the scenes to know how it's working. Otherwise, it's going to be a bit of a challenge to fix it. So in the good old days, actually, 10 years ago, 5 years ago, people like us operating Ceph, we would learn how Ceph worked because it didn't work that well. So things like file store on XFS was not working that well. And, nowadays Blue Store is so much better, and Crush was broken in many different ways in the past. And, we had new versions of Crush, and admins learned about how it was breaking and how to fix it. We used to ask ourselves, like, how many PGs? I mean, now there's like an autoscaler. We don't think about these things anymore. We used to have imbalanced OSDs, like wasting petabytes and petabytes of storage, or, lots of your storage. And now it's just like solve problem, balancer on. Ceph used to be actually really challenging to even install. And now just like one-liner commands with our orchestrators like Ceph ADM and Rook. So it's pretty like rock solid now. And I'm finding in the different kind of conversations I have with Ceph users that they don't even have the opportunity to learn how it works inside. So they don't really get the chance to learn how it works. When it breaks, it's even more challenging. So in this one, I'm going to talk a bit about how it works. Before getting into that, the other thing is that we used to talk a lot about why Ceph was good, and we don't even talk about why Ceph is good anymore. So I just wanted to put in a couple of slides just to remind ourselves, at least from my point of view, what separates it from the other storages, the other SDSs, the other open source storages even. And just remember, the main thing is that with Ceph, you can take just low cost commodity hardware, add some Ceph software, and get feature rich enterprise storage. It's giving you block and object from a unified storage system. This is still a kind of concept that's not happening in other storages. You just teach your team to operate one thing, that's Ceph, and it simplifies everything. We also we used to talk about Crush as a kind of secret innovation, and it really is. And things like Crush and the way that Rados works, and the things that we'll talk about today, like how PGs work, like these things were like invented in Ceph, and other storages are still haven't really caught up to what Ceph is doing there. Um, something I like to say about Ceph is that it's organic. In the first memo that we proposed it to CERN, we called like organic storage for Ceph forever, and it's really is that. So I still see other organizations using storage and thinking about migrating data every 4 or 5 years for hardware refresh. With Ceph, you don't have to do that. And with other, I learned recently, like other quite popular software-defined storage, you can't even add another server without shutting down the whole cluster. Like these are things we just take for granted in Ceph, but it really sets it apart, right? We have Blue Store. We have like an optimized low-level system to access block devices in an optimal way for our storage. This is also quite unique. Couple more things, like it's safe. Ceph is safe. We have all kinds of features mirroring across data centers, stretch clusters, all of those kind of enterprise features like worm that are needed in object storage. It's ready for kind of all kind of disaster recovery scenarios. It's still scale out data and metadata like performance. So Ceph is a CP system, so it's like consistency first, performance second, we can say, but it does provide performance for the most demanding applications out there. And it's still one of the things we always used to say about Ceph, and we still can say it, is that Ceph is trendy. It follows the trends. Over my career, I've gone from HPC to private clouds to containers, data lakes. Ceph was like behind it the whole time. You can just keep that one infrastructure there. And then, of course, I almost forgot, it's like open source, no vendor lock-in. The users retain the control. So that's my like 2 cents why is Ceph still awesome. So, but today is more about internals, and it's more about like how we store data. Why do we have PGs? What's the role of Crush? What's this Upmap thing, and why do I keep talking about it? And if everything goes well, some demos, the demo gods behave today. Yeah. So first of all, like how does Ceph store data? And by the way, this talk is like, let's call it like an intermediate talk. I'm not going to introduce like what is Ceph. I'm not going to talk about what are OSDs or what are mons or things like this. All assumes that you've operated Ceph already, but you just maybe need some insight into the internals. So this is a question: how do we actually store the data? Because the problem is, we say we have something like a file. Maybe it's a disk image. Here, there's like a disk image. Maybe we have like a document or a movie or an image. We know that we can like sort of split those into objects, and we know that underneath Ceph there's like an object store. This that thing called Rados, and we know that we're putting things into pools. So those are all things like we know. But then it gets a little bit fuzzy, right? And then we heard about PGs, Crush. We know there's different OSDs. Like, how does that all work? In the olden days, in like conventional storage system, they would use an index. So they would have like objects, maybe like millions or maybe even a billion objects, and they would just like use some kind of algorithm or some kind of placement procedure, decide which server is storing the data. It should be storing that object or file, and then just store it there. Even that's like, say, an old school but parallel system. So you'd have a central database for it. Databases are, of course, like something like that would be hard to keep HA, hard to scale in performance and in size. So in Ceph, we do something different. We calculate where the data should be placed. And I always call this like two-step placement. So first of all, like a pool is physically implemented by something called placement groups, and I'll show in demos like concretely what this stuff is. It's split into placement groups where what you do, it's two-step placement. So the first step is you take an object, and there's actually like the math is written right here, right? You just hash the object name and you modulo the PG number. So a pool has got maybe 256 or something, 2 to the power of something, maybe 1024, maybe 16K for very large clusters. But you just simply take the object name, you hash it by the number of PGs, and that decides which PG that the object is going to be placed into. So that's a very like uniform hash. Each of the placement groups will have pretty much the same number of objects, within a very small margin, with a small variance. And you see, you notice I didn't talk about anything like crush or anything yet. This is just a very simple sort of like divide and conquer. Let's shard the objects over these PGs. So that's step one of the data placement. Step two is we actually decide where that PG should live, and that's where we use crush. So the PG, like this one, for example, 1.0, will say crush, we'll ask crush, hey, where should this PG actually be stored? And crush will tell us, okay, so on OSD 1, 3, and 4. And then that's voila. So that's the placement. Step one, hash the object name into a PG. Step two, ask crush where the PG should be stored. And I think we all know that like this is all stored. This is not like a database or something. This is just, we have all of these OSD maps, crush maps that get shared around. Everyone in the cluster knows can do the same calculation, and therefore we can just do this calculation quickly. Yeah. So you might ask, like, why do we have PGs? So if we're like mapping objects to PGs and then mapping those PGs to the OSDs, like, why is it that two-step thing? Why didn't we just map the objects directly to OSDs using crush? So in that scenario, we would be like, ask for every single object, we would ask crush, for example, like which OSD to store it on. And the effect of that would be, right now, if I go back here, like right now, you see like these OSDs, these three OSDs, you can call them like peers because they share something. But if you were actually hashing every single object one by one, it would mean that like all OSDs would peer with all of the other OSDs, which would be a kind of disaster for high availability, because it would mean that like every single time that you had 3 disks failing in the cluster, you would have data loss. So consider like a super large cluster, like 5,000 OSDs. There's actually like 125 billion combinations of OSDs that can fail that would cause data loss. That's just like 5,000, pretty much to the power of 3, right? But in fact, like in real life, when we operate Ceph clusters, we know that we have something like 100 PGs per OSD. So actually only like very few of those 125 billion combinations can cause data loss, because we're not connecting all of the OSDs together. Most of the time, when 3 OSDs fail, they're not related to each other on a large cluster. Yeah, and this is some kind of like, Ceph was doing this since the beginning, but like even like research in the 2010s was like, oh, maybe that's a good idea. Systems like HDFS or whatever Facebook was doing were actually just like combining all the disks together. And then someone wrote a paper called this is a good thing called copy sets, and they found that if they actually like limit the number of combinations of concurrent disks in the cluster, they can really like limit the number of failures. So this is like the probability as the number of nodes, this plot here in this paper. I mean, you can, I'll put the slides later somewhere and you can click that, but this is kind of showing the probability that you'll have data loss with this number of nodes in a cluster. And with some of those other systems, it was like immediately going to 100% with 3 failures, right? But Ceph has always been down here. It's like very, very unlikely that you'll have data loss. Yeah. Now there's like another reason. There is another reason that I actually forgot about until recently. It's like one of those things you just take for granted again in Ceph. So the question would be like, this is all so complicated, PGs and stuff. Like, why don't we just use RAID like we used to? And then, why not? So the main point there is that it's like PGs give us super fast parallel recovery from failures. So if you're replicating disks, like whole disks like we do in RAID, or even doing like whole disks parity stripes like RAID 5, RAID 6, you need to have like an empty spare ready to go. First of all, it's a concept you don't need in Ceph. And then second of all, like the recovery is like limited by the speed of the disk, because you have to like write to that single disk that is your spare. In Ceph, you replicate PGs. So if something fails, you actually have like all of the OSDs that were peers work in parallel to do that recovery. And I think those of us that have been operating Ceph, we know like you can recover when you have a disk failing. You can recover in a matter of minutes, not like hours as it would have been with RAID arrays. And that's that's especially important now that devices are getting larger and larger. 20, 30, and sometimes even like 60 terabyte OSDs are now, or devices are now becoming available and becoming the norm even. So that's, it's like these are all of these things it's like, this is part of the magic of Ceph for me. It's like things that were done several years ago, more than a decade ago. And like today, it's still showing it's why Ceph is sort of future proof and why it's still relevant, more than relevant. Okay, so then what's the purpose of Crush, right? So like Crush was kind of like, even like, let's say to the salespeople, it was like the magic, and to us, sysadmins using a storage thing, we were like, "Oh, Crush, this seems like amazing." But like, what is it? We know it provides like a language to describe the data placement according to your infrastructure. So this is all about this concept of failure domains. So you want to be able to like replicate across servers or racks or rooms, or do erasure coding, like mixing different device types, things like that. Of course, that's Crush. So it's really fast. It computes object locations in like microseconds, and those Crush maps are really tiny, so they can be shared between servers and clients. And it means like, so with all of those with PGs in Crush, it means that we don't need that big, large index of files. We don't need that large DB like other legacy storage systems. So that's just why like we can call it like exascale. Yeah, but Crush is imperfect. So if you when I talked about that two-step data placement, like the first step is pretty good. It's pretty uniform, but Crush is not like that. Crush, because the statistics are lower, and because of some actually like small flaws in the way that it's used, it's actually almost impossible to get a perfect data distribution on your cluster using Crush alone. So like, why is this a problem? A Ceph cluster is full when a single OSD is full. So if we have a cluster and like on average, the cluster is like 70% full, but like one OSD is an outlier and it's 90% full, that means the cluster and the pool are effectively 90% full. As soon as one OSD gets like all the way to the limit, that's it, kaput. The pool stops doing IO. And Ceph even has safeguards to like shut down the IO before it gets to that point. So there's also, of course, like OSDs with more data do more work. So like you really want the OSDs to be balanced in terms of the percent utilization. And like, why does it happen? I already mentioned like quickly. So it's like even if you have like, there's some basic math behind this, like the expected distribution is actually 10% standard deviation when you have about 100%, when you have around 100 PGs per OSD. So that's like, that means that you're like, up 10, down 10. It's like you have around a 20% variance between the top and the most used and the least used OSD. So that's like 20% wasted capacity in your cluster just out of the box. There's also like a small subtle issue where it's like, actually the way that we use the weights of OSDs in like multiple rounds of choosing, like choose the first copy, okay, it's OSD 3. Choose the second copy, we use the same weight for all the other remaining OSDs. But that's like, if you have different Crush weights in the cluster, it's actually like mathematically wrong, because the relative weights change for the second and third and subsequent picks. So that's something that we call the Crush multi-pick anomaly, and it's just sort of something that's very difficult to solve. So all of this is like, Crush is imperfect, so we need something else. And that's like, summary up to now, the PGs are great for, like we talked about, availability, for recovery and other reasons. Crush is this great language, but it's imperfect. So like, you might now ask, okay, like we have this thing now, we don't need a huge index. Like, why don't we just maintain a very small database in Ceph, which like, why don't we just place the PGs like exactly where we want them, and just maintain that database? So that's, you know, if you're thinking logically as like maybe a developer or something, how can we make Ceph awesome? And that's exactly what we do. In fact, that's exactly what Upmap is. It is effectively like a database of PG locations. And it's been around now for a while. It's been around since the Luminous release of Ceph. So, you know, more than 5 years ago or whatever that was. And internally in Ceph, you see commands like Ceph OSD PG Upmap, Ceph OSD PG Upmap items. Those two things are like subtly different in how they work. There's also now, I think people are paying attention, there's also Upmap primaries for each feature as well, so that you can actually force which of the OSDs is the first in the list. So which one is doing all of the I/O with the clients. So this is what this is. This Upmap is a database of PG locations. This command is the one that's used the most, and this is used by things like the balancer. And actually, like, so technically what it is it's like the way you use this is you say, for this PG, say like 1.ff, it's like if you see OSD1, then replace it with 2. And if you see OSD3, then replace it with 4. So it's like a kind of like lookup table. It's like a lens that you put over top of Crush in order to refine the placement. So in the end, yeah, now we can call it like a 2.1 step placement with PG. So we have the same picture that we have before. We have objects put into a pool. The pool's split into placement groups where we, by hashing the object name, then we use Crush to map it to OSDs. But we do like a small little correction at the end. After whatever Crush tells us to do, we just do like a small correction with using these up maps, and then voila, we can like, let's see what we can do with that basically. So how is it used? The main thing that it's used internally in Ceph is it's used to balance the data optimally. So for example, like if you're running Ceph DF and it says that your cluster is like 50% full, but like you look, so in the raw items, it says the cluster is 50% full. But then actually, like if you look at a data pool, it says it's 75% full. It's like, what does that mean? And what that normally means is that it's like things are actually imbalanced. And if you look at the Ceph OSD tree, you would see, oh, this one is like the Ceph OSD DF tree. You would see that some of the OSDs have more data than the others. And if for some reason you have like a very old cluster and you don't yet have the balancer enabled, then basically, like, you know, TLDR, just enable it by now. There's some very few commands. If you've installed a new cluster within the last 4 years, this is already on by default. But if you have something older, you know, a little bit longer beard cluster, then you can enable it like this. And I've shown here like a few of the commands that you can use to actually configure it in like a more, let's say, a more usable way. You can set like when it runs so that it's only moving data. Like for example, in this case, it will only move data. It will only balance things during working hours. Maybe that's important to you. You can also set this like max misplaced. So max misplaced is used for the balancer to decide like how much, if it like decides to move one PG from one OSD to another, it's like now all of those objects are misplaced. And this configuration lets you control how much work that it queues up on the cluster. So by default, it's 5%. And then in this example, it's like 0.5%. And then there's this is basically, it's one of the first things I ever adjust on any cluster I ever get my hands on. This is the max deviation. And this is what this setting is like how many, the balancer works to make the OSDs have the same number of PGs effectively for each pool. And it stops when it sees that they're within this max deviation value, and the default is 5. So that's actually not that good, because it means that for each pool they can be like 5 PGs out of whack, and you actually don't really balance things that well anyway out of the box. So I always like strongly recommend set this one to 1. That's as tight as Ceph can get it. And then yeah, just switch it on and it'll work in the background. And if you have, you know, large or small clusters, you're going to save lots and lots of capacity. You're going to for sure recover more than 10, maybe 20% of usable capacity. So that can, you know, that can amount to tens or hundreds of thousands of your local currency. Yeah. So let's see. Oh, I have this video. I love this video. This was, these things were all super trendy back in like, in 2019. I think we had Ceph Day maybe in Barcelona there, or Cephalonicon in Barcelona. And my good friend Tom Byrne over in the UK at STFC, he made a video showing the impact of switching on this Upmap balancer for their large cluster with 4,700 OSDs. And it's just always exciting to watch this one to see. So what this is showing, before I'll click play, this is a histogram of the OSD utilization effectively. So it's saying like an OSD on the x-axis is like how full is the OSD, and on the y-axis it's like the number of OSDs that are that full. So it's like bins with a histogram. And you can see at the beginning, like some of the OSDs are around like 40-45% full, and some are up to 80% full, but like on average they're around, what would you say, like 65% full. So this is exactly that situation I was talking about. Like now this cluster is going to be full as soon as these 80% full ones are reach the top. So you really want to like squeeze this down, and let's see how it worked. I think it took they switched it on. It took a few days. It started moving things around, and there you go. Like pretty quickly, it reached a pretty tight distribution. So still around 60, 62, 63% utilization. Oh, it even says it on the plot, like 63%. So the standard deviation dropped from there like 7.5 down to, let's see where it gets. Probably like two or so. Yeah. So, and that's as tight as it could get on that cluster. Maybe they didn't know what the Upmap max deviation value could have got it even tighter. But there you go. So that's the balancer. Switch it on if it's not already on, and that's how we effectively use Upmap the majority of the time. Let's come back. Oops. There we go. But like this talk, I keep talking about this thing and keep presenting this because as soon as I learned about this Upmap feature when it came out in I guess 2019, it's like suddenly like the light bulb went off. Oh, I can do some more, I can do something else with this tool, because, and it's at CERN we were, you're doing Ceph maintenance at scale. You're always in the position where you need to add capacity or replace servers or change crush rules or change OSD weights or change crush tunables. Like I was saying, back in the day, we had to do that often. And every time it involved like moving large amounts of data that can last lots of days, maybe sometimes weeks. You don't know what kind of impact it's going to have on the users, if it's going to cause an outage, if like the website's going to go down, and there's no way to undo no way to undo your change if you started something. So this was always like, I always show this picture. I've given something like this talk a few times now, and like this is like a picture of like me or us, Ceph operators. You have some kind of like you have some kind of Ceph, some Ceph status. You want to add some servers, you want to change whatever, and like you just want to like click that button and then hope it works. And if you've done it a few times, you realize that this is a bit of like a traumatic question. So like the idea is like, how can we make it better? So this is what I'm proposing now. It's that, suppose you want to, for example, add, you want to do some maintenance, and like this is like concretely what it is. It's like you want to, for example, add capacity or drain some hosts or change some tunables. Immediately you're going to see some kind of like, you'll do that step, and then you'll see lots of objects misplaced. Like here in my silly example, it's like, there's a progress bar showing that it's going to take 6 weeks to complete. So the question is like, do you want to just like wait those 6 weeks, or can you run some kind of like magic script? And ideally, we want something magical that you just run and it gives you like health okay. So here is one of those like real clusters, with lots and lots of data misplaced, lots of PGs remapped, backfilling thousands, 23%, 23% misplaced, millions, tens of millions of objects that needs to move around. What if the question is like, why don't we just use this like Upmap thing now to like remap the PGs back to where the data is? If we could do that, if we could use this tool to say, actually, so I've made that change with Crush or by adding the host or whatever, why not just use Upmap now to say the data is in the correct place? Don't move it, just leave it where it is. So that would be a way, for example, to say that these objects are no longer misplaced. And that's the whole idea here. So, we wrote a magic script that did something like that looked at where the data is and actually move it. It creates all of these like Upmap items entries, and then you get health okay. So this is the basic idea of what I'm always proposing how to do Ceph cluster maintenance, is that you can make changes to the cluster, add capacity or whatever, do something out of the box that's not a core feature of Ceph, and you'll have health okay immediately, and data will not be moving immediately. So again, like this, health okay is nice because it means that we can there's when the cluster's in a warning, you're getting alerts all the time. And here I just showed with what you can do something very quick to get a health okay quickly. And then behind the scenes, the automatic data balancer is going to do the real work of actually moving the data around. So like we said before, there's that built-in automatic balancer that's noticing, oh, this OSD is really full and really empty, and it starts moving things. It starts creating Upmap entries itself. Basically what it's going to do is all of these Upmap entries that we created here at this step, the balancer will just remove those slowly, but it's going to respect all of those rules that we set, only run between these hours of the day, or only have this many max misplaced objects. It will do all of that to keep things, sort of throttled to a rate that's that we control. So it gives us control. Voila. This is the so Upmap to the rescue. There's this script, I've shown it lots and lots of times. And I've mentioned it on the mailing list lots and lots of times. You can download this, just search for Upmap Remapped. DigitalOcean has a similar tool, PG Remapper, with some even more interesting features than just that. And yeah, that's basically the talk. And then I wanted to do some demo. Maybe before, I don't think I'll come back to the slides. I'm going to switch to a shell and then do some demo and probably answer some questions. But before that, let's maybe just do the quiz time thing. So I don't know I think there was maybe one question, a couple of questions on the chat,
Yep. Yeah, there's one in the chat, and for everyone who has joined, feel free to continue to put questions into the chat, and Dan will go through those at the end.
Thanks. So here, I wanted to address this little poll, and I hope people have gone and clicked. And when I looked this morning, I saw that most people, there's a few people thinking that Ceph is just a kid. There's a few more saying that it's, most I think are thinking that Ceph is between 10 to 15, or I think the peak is at all grown up, 15 to 20 years old, which is actually totally exactly what I would have answered as well. Until I took a look. I mean, I guess age, there's different interpretations that you might think of how old is Ceph. But for me, I just look in the Git log. And if you look in the Git history, Git log -- reverse, you'll see the first commit to Ceph was on June 24th, 2004. So it's almost, we just had a 20th birthday. I'm not sure anybody noticed, but it's 20 years of awesome Ceph. So Ceph's 20 this year. And actually something really interesting, look at this, the first commit was already include mds.h. Ceph was really all about CephFS at the beginning. That's kind of interesting fact about this. All right. So I can just before showing a demo, we can do just these couple of questions. So Greg's asking, I don't know if people want to speak up and talk a bit more as well, but Greg's saying, today I fixed a full OSD with degraded objects destined for it using Ceph OSD PG Upmap items for the first time. Very smooth, even though it was a bit laborious. Yep, good to hear. So Greg, I would say try also this tool, either PG Remapper or Upmap Remap. Just Google for these things, you find them right away. And it probably does exactly what you did by hand. Nichols asking, how would we use Upmap for the fleet scenario with upmap remap. So rack 1, replica 1, 2, rack 2, replica 1, 2. So Nickel, maybe you can, I'm not sure I understand your question. The idea with upmap remap would be, for example, if you're in that scenario and then you're like adding, if you have like rack 1, rack 2, rack 3, like you add a fourth rack, you can just like add it. Lots of data will be misplaced, and then you run this upmap remap tool, and it will
Sorry,
yeah,
sorry. I just want to elaborate on my question. So we're not adding a fourth rack there.
Yeah.
We have a significant size cluster based on those crush rules in racks, and I know it's not best practice, but we only use 2 replicas for performance reasons.
Sure.
We're adding new servers to the same racks within the same racks and decommissioning the old servers in that rack as well.
Yep.
So would you fleet one rack at a time and use the upmap script per rack and wait for the rack to fully converge before you move to the next rack? I think that was my question.
Yeah, I mean, so there's lots of different ways to use it. The basic golden rule is if you have, so first of all, these days, Ceph is pretty good at like draining servers or moving things around in most cases. There are some very like there are corner cases when you have like, say, billions of small objects or very large servers or maybe unstable servers where out of the box Ceph simply doesn't work. So first of all, just like, try to do the normal thing, the normal just drain or whatever, set the crush weights, however you want to use it. If the golden rule of when this tool is useful, and I'm going to show a demo. I'm going to try to show a demo, although you guys will see something very interesting that I noticed yesterday when preparing for the demo. The golden rule is, it's like if you have, this is the scenario when you can use this tool. The scenario is that you look on your Ceph status and you have lots of remapped PGs. So remapped and misplaced objects. If you have remapped PGs, misplaced objects, so that can be a result of like maybe you're setting the crush weight on a server down to 0, or maybe you've added a server, something like that. It's like now the OSDs are or the PGs and the objects are misplaced. You can run these kind of tools, and it will just like decrease this number down to 0. That's it. That's the whole thing. So like, why would you even do that? It's because of that issue I said, where like maybe the change you've made is going to take like a long time, maybe more than a week or so, so that's the scenario. And I should also note that this stuff only works. This stuff will never break the failure domain crush rules that you create. So you'll never be able to, if you make a change, which is like changing the data layout, maybe changing the failure domain, you can't create upmaps that override those. That's something that like I've often wanted, like, please let us do that. And you used to be able to do that due to bugs, but nowadays you can't do that. So Nick, does that kind of explain? Maybe through the demo, I'll show it a bit. Yeah.
Yeah, I will reserve my questions for later once you're done.
Yeah. Okay. So Joel's asking, like, does the balancer modify the upmap items? So yeah, totally. Actually, what it does is it just like orders the OSDs by like the most overfull, and it also like does the reverse, like the least full, and it just kind of moves things around. And of course, what it looks at is, before like creating new upmaps, it looks if there's any upmaps that it can actually remove. So if there's like, because the upmap is technically like something in the OSD map. I'll show that in a minute. And like it just removes those entries. And then, yeah, thanks, Tom. Tom's question, I don't know if people can see it, but like when he's adding hardware, adding OSDs, PGs are put into the recovering state. Okay, but that's normal, right? And they can't be moved with the upmap. I think so. I think I see what you're seeing as well. And this is something that's been coming up more and more. Basically, I think that probably those PGs were also degraded for some reason, which is unknown, and I see the same thing. And maybe it'll even come up my demo. It might even ruin my demo today. So let's see, Tom, and let's see the others. I'm going to switch to a shell and try to explain a bit about how this how this all works visually. So switch to a shell. Hope people can see it. I have here like a tiny Ceph cluster. It's actually a really fascinating cluster because it's just 4 VMs with attached. This is just all on a VM system. 4 hosts, 4 OSDs each. Each host has only 2 gigs of RAM. So can you believe it? I got a 16 node Ceph cluster running with only 2 gigs of RAM on each node. Just trying to have a little fun sometimes. So like all of that means is that everything I do here is going to be like pretty sluggish and weird, and you'll see crazy stuff happen. But that's okay, because that's the kind of stuff that Upmap Remap is meant to help. So here, I just wanted to show like a bit about what this is actually doing. We have, so you can see with Ceph. So first of all, Ceph OSD dump, I just want to show, like, normally you would have, we have our Ceph OSD dump. Normally you would have, like, if there were any upmap here, you would have, like, you would grep for upmap, you would have something, you would have some entries there. So I'm just proving this cluster actually has no upmaps in it. So this is the OSD, the OSD dump, it tells you like where are the OSDs located, when have they been up, are they up or down or whatever, and then the block lists at the bottom. So this cluster currently has no upmaps, nothing to show you. You can see with Ceph PGLS, this is like, I don't know if people run this one often, but this is a kind of verbose output. It tells you everything about the PGs themselves. So for example, like, I think we'll focus. Oh, can you guys not see my screen? PR is saying you don't see the screen. I can see it in the demo.
I do see.
I can see it.
Yeah.
What do you actually?
Well, I see.
It's interesting. It's frozen. It is frozen. On the left, that's weird. If I hit enter here, yeah, actually it's frozen. Let me just reshare it. I don't know why that's happened. That is weird. Yeah, this is where I am. So if I hit enter here, yeah, that's working now. Thanks.
The demo gods just wanted to test you, Dan.
Yeah, well, it's not going to work anyway. People are going to laugh, and so it's working now apparently. Okay, so yeah, this is this like I was showing Ceph OSD dump, so it's showing where the OSDs are, and this cluster does not have any upmaps. We'll create some actually to show how this works. With Ceph PGLS, you can see there's lots of things in Ceph PGLS. Like, what we're going to focus on here is we'll take like one of these. These are the PGs, right? It starts wrapping around so much. But the interesting thing I wanted to explain before like going on is like, what does all this mean for what concerns this like up and acting column here? Because this is really what when we're placing the data, these are the important things. So for a given like PG, I think, so maybe in my history I have it, like I was going to use awk and just like print exactly the right columns. So we have like column 1, and I think it was it 14 and like maybe 15. Let's see if my memory serves. Oh, probably 15 and 16. So then let's just look at the top of that. So here's like for any PG, like this is what we call the upset, and this is what we call the acting set. So the acting set is the list of OSDs that are currently serving IO for a PG. So this means that like for PG 1.0, like OSD 3 is the primary, OSD 13 and OSD 2 are holding the replicas. And on the left here, you can see like on my small cluster here, like OSD 3 is there, OSD 13 is on a different host, and OSD 2 is on a third different host. So you can tell I'm doing like host-wise failure domains here. And the upset, this like 3.13.2, it's the same. So in any cluster where you have like health okay and all the PGs are active plus clean, that like what that means is that these two things are the same. When you make a change, when you, for example, let's do something silly here. Let's do like first I'm going to do like Ceph OSD set no up. Okay, this is just a little trick I'm going to do because what I want to do is actually, and I'm going to do, Greg's asking what's the P5, P15. That's just who's primary. So P3 means like 3 is primary. P3 primary, P5 primary. It's just who's primary. Yeah. So I'm just doing a little trick here. You'd never do this on your real cluster. I'm just going to like, here, I'll do like watch Ceph status just so you guys see what I'm doing. What I'm going to do is like fail an OSD. So I do this by like setting no up and then telling like my OSD to go down. So this is a little trick. You can, if you ever need to like kind of like poke an OSD to repeer, and you don't want to like SSH in the host and systemctl restart the container or Ceph org like restart that OSD, you can do this. You can just say, hey, OSD, go down. And it will, it doesn't restart the process, but it just like reboots itself internally. And because I have the no up flag, it doesn't, the mon's not letting it go up. So it's just ignoring all of its up messages. Now I have this down OSD. And I did this because I want to now show you like what happened to those, this same Ceph PGLS. And you see like now for that like 1.0, it's like we have only 2 OSDs listed here. OSD 13 and OSD 2 because we just marked OSD 3 down. So now like the acting are 13 and 2 and the up are also 13 and 2. It's the same. So that's why, you know, with Ceph status, we see that things are undersized degraded, but nothing is like, there's nothing backfilling, nothing recovering. We can make that happen to like backfill and recovering. Simply what we have to do is, so first I'll also do another trick. I'll like set no recover because I don't want Ceph to heal anything, but then I'm going to actually mark that OSD out. I'm going to pretend that it's like going, that the disk has now been out a long time and Ceph has decided, okay, it's not coming back. So let's mark it out. So it's like Ceph OSD out 3. So this is now like the disk has failed. It's been out, failed for 15 minutes, and Ceph is going to rebalance the data. With Ceph status, we'll see things like now there's a lot of like degraded and remapped and like recovering PGs. They're all still active, but you know, because I have this no recover flag set, nothing's fixing, nothing's getting fixed, and this is all just I wanted to show you what happened to those PGs. So now, again, just focusing on the first one, we have the acting set is 13 and 2. So that means like 13 has the data, he's the primary, 2 is a replica because 3 is now gone. But the upset is now 13, 2, and 15. So Crush is now saying, oh, that OSD3 is out. Let's find you 3 replicas for PG 1.0. Oh, it's found like OSD 15. So let's look at the tree again. OSD 15 is here. By coincidence, it's on the same host. So 3 is now replaced by 15 for that PG. But you see like the acting set has only 2 OSDs and the upset has only has the 3. So it's like, this is the whole idea. It's like acting is like now and up is like where things need to be. And that's the whole idea. So we could actually do, let's do something just to show how Upmap works. We could do like Ceph OSD PG Upmap items. We'll do like for 1.0, we'll replace OSD 15 with OSD 14. This is the idea. We've now like set this like 15 to 14, and we can run this PGLS again, and like the 15 was replaced by 14. So there we go. That's the whole concept of how this works, and what all these up and acting mean. I'm just gonna like undo, I'm gonna set OSD3 back in, and I'm going to actually unset no up to get things back to the way they were. This will take a little bit to heal. And now I wanted to do like a demo of the of actually Upmap remapped. But this will be a bit hard because of what Tom noticed. There's a couple of questions I just wanted to get to. Greg's asking, sometimes you see none or maxed int for the degraded shard. So Yeah, so none is that you see that for erasure coded pools, none or maxent. And that's because, so if you will have noticed, like when you create crush rules for erasure coded pools, do I even have one on this cluster? I don't think so. Oops, I just switched on the transcript. Switch that off. Yeah, because I typed the letter C and it like in the window had turned on the captions. All right. So I don't think I have an EC pool, but what that, oh, I do. There we go. Yeah. So this is the point. So when you do like replicated base rules, it uses this thing called like first N. And when you do erasure coded pools, it uses this thing called in-depth. Okay. These change the way that Ceph actually like chooses those replicas, because in those, let's call them like shards, in a replicated pool, like any OSD is the same. They all have all the data and they all can be like first, second, or third, or fourth. It doesn't matter. But in an erasure coded pool, you can't replace like the first OSD with the second because they have different data. So if you're missing like the second one, if it's the second one that's failed, like you can't just simply promote whoever had the third shard to now be the second, because it's like it doesn't have that piece of data that the second one had. So that's why like the way that Crush outputs the OSDs, it actually just puts a gap there. It says, instead of saying like, now instead of having like we have a list of 3 OSDs, it's like we still have a list of, say if it's 4 + 2 erasure coding, we still have like a list of 6 OSDs, but now maybe the second one is missing, and that's where you put in, it would put in the like none, or it would put in maxent. That's what that is, Greg. So voila. Okay, I wanted to show a scenario where you would use upmap remapped, but the challenge is that when I was doing this demo earlier, preparing for this, I found that doing simple things was marking things degraded, and I think people saw it there. And this is what Thomas mentioned. This is not the way that Ceph is supposed to work. And around Nautilus release, Nautilus or Mimic or Nautilus, something regressed, and a few of us have their like open trackers and pull requests. We've been trying to fix this, and there's actually work on this week even, but it might make this demo kind of boring. So what I'm going to do is I'm going to go back to this situation where we have, let's say we'll change something in Crush, and then we'll try to use like Upmap to Upmap remap to like sort of fix things for us. And I hope that it goes somewhat well. So first I'm going to set the no recover flag again, just so that things pause a bit. And then what I'll do is let's just, for example, let's like pretend that there's different ways we can do this. Yeah, so let's show the thing that doesn't work. So let's like pretend that actually now we've got like a bigger disk or something like that. So we'll just say like Ceph OSD crush reweight OSD.3. We'll say like, I think people saw before, these were like 0.5 terabytes. Let's say it's like it's like 1 terabyte now. So now you'll see our like Ceph OSD tree shows that actually like this OSD is much bigger. And now things are going to appear. Yeah, and this is exactly what is not supposed to happen. So this has nothing to do with Upmap, whatever. This is like Ceph Quincy misbehaving. So what I've just done, I haven't stopped any OSDs. I haven't done anything. There's no reason for anything to be degraded or undersized, but it is. And this is actually like a Ceph bug. So normally you would be able to actually just like run Upmap remap in this scenario. I'm going to see if I can fix this situation. This sometimes works. Let's see if I can get this one to not be degraded. If this works, then we can continue. No, it didn't work. I'm trying to get all of the PGs to be not degraded or undersized. So that didn't work. Okay, so that sucks. This is like Ceph ruining my demo. most of the time, I don't know what causes this bug. I have a feeling that because this cluster is so small and under-resourced, like there's some kind of weird race condition that this one's triggering it more. On your like real clusters, you will get a few like this, which are recovering or undersized degraded that shouldn't be, but it's not like all of them, like in this case. So let's put things back the way that they were. And what I'll do is I'll like switch on the balancer and I'll get the balancer to create some upmaps. Ceph OSD, I'm gonna like reweight it back to where it was. Actually, I'll just like let it heal. That's fine. Ceph OSD unset, recover. The nickel while you're going, yeah, nickel. So you can use upmap remap anytime from Luminous onwards. You can use it all the time, and you can actually run the script anytime. It will never do anything bad. So I mean, I'll try to get a situation where you can see where we can actually run it. This is now recovering. Go, 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 go. This like super slow cluster with only 2 gigs of RAM. It will get there. And I'm just going to do like set balancer status so that you see that right now the balancer is off. I'm going to like turn on the balancer. It'll like move some things, but I'm going to set no recover so that it can't move things. And then I'll use upmap remap to like fix those. That's the little trick I'm going to do to show you guys how this thing works. So I just wanted to like show that I've configured this balancer with a couple of things. So like I said before, that upmap's max deviation, I've set it to 1. And I also, like in this case, I've set the sleep interval to 1. By default, the upmap balancer runs every minute and it like moves 10 PGs maximum. That's the default configuration. So I've just for the demo, I like want it to run every second and make it like quite hyperactive. So I'm going to set that no recover flag again. And I'm going to turn on the balancer and then like see if that gives me the situation that I can show you guys. So it will, okay, now we have, voila. So now I'm going to switch it off real quick. So we have 11 remap PGs here now. It's already degraded. Ooh, Ceph is really broken here. Something's wrong. This is 1727. That's interesting. Yeah, are there any here that are not degraded? There's a couple that are not. So I can do the demo anyway. So like pretend that we got in this situation. There's some degraded, some misplaced. Upmap remap can help with this situation anyway, even though the PGs are not. Let's run the script. Let's see if it outputs something useful. There we go. So it's going to, oh, like interestingly, yeah, exactly. So what it's going to do, so Ceph OSD dump, pipe to less, like I'm now looking at the OSD map again on the left, and you see those like PG upmap items entries that we have here now. These were just created by the balancer. We switched on the balancer for like a minute. It created these and it's saying, okay, move from like 6 to 13, move from 0 to 7. If we look like Ceph OSD DF tree, oh, this is pretty ugly, but like in this column here, it's very hard to see. But in this column here, this is the number of PGs on each OSD, and it's like ranging from like 12 down to 3. So it's quite imbalanced. So that's why the balancer was decided, okay, it's going to move some things around for me. And that's what these are. Now, when I've run upmap remapped, so I've just run this command and it's just printing some output. Actually, it's printing stuff that you can then pipe it to a shell and and then run it. It's basically upmap remap is going to like remove all of those upmaps and it should help things. So let's just like run those and see what happens. And what I'm looking here on the left is this like 7% degraded. That's the thing that should decrease. And exactly now it's back to, there's one that's still recovering because it's some kind of like peering scenario, but the PGs are all active clean again. So it kind of like, it worked for us. Let's Yeah,
And
that's
I
the basic
didn't mean to
map.
interrupt. I just want to be cognizant of everyone's time here. We're just at the top
Sure.
of the hour.
Yeah, I mean, effectively, that's the end because I constructed a scenario where it showed where you would use it. There is that little Ceph issue that I'll like repoke the tracker bug. But yeah, I mean, so that's it. So this kind of tool, it's the more I share it with people, they find like scenarios where they can use it, and it seems to help quite a bit. Give it a try. Feel free to reach out to me, LinkedIn, email, whatever the kids are using these days. And yeah, so if there's any other questions, we can hang around for a little bit, or we can wrap it up. But yeah, thanks for listening.
Thank you, Dan. This was wonderful.
Thanks, Dan. It was actually you that helped me use it some months ago to help repair our cluster.
Awesome. Yeah, it often saves the day. That's the thing.
Yeah, and I actually did use it today to tidy up a whole lot of misplaced objects before then
cool.
manually stepping in and trying to use the tool myself for one PG that was still wrong.
Yeah, it usually gets pretty close to it. Sometimes it can't solve like every scenario, but it gets pretty close. It gets you closer to the finish line. Yep.
And it's the confidence that it builds as well. Like having it output to just to dump a bunch of commands that I can go, all right, well, I can run them myself or stick them in my own script and manipulate things if I want to.
Yeah, great.
And I'm going to get my team to look over this again because it's good. Yeah, again, confidence building.
Awesome.
And to that point, if anyone has team members that couldn't join today's call, when we'll put the recording on Clyso's YouTube channel as well for everyone. All right. Have a wonderful day, everyone. Thank you.
Cheers.
I see there's Devender's asking a question. I can stay and answer. It's okay. Or did Devender leave?
Hi, Dan. I'm still here.
Oh, hey. Yeah. So your question is that the weight?
My question is, I saw in your cluster when you were demoing, it's showing OSD weight was not 1 as default nowadays. Every cluster, when you deploy the OSD weight, if you have the same size, then normally you don't need to change the OSD weight from 1 to some other lesser. But so if it is 1 as default, do I still need to use this script, or the PG balancer as a default it's remain on? It will be balancing everything.
Yeah, I mean, the balancer will actually balance everything anyway. You don't need this script to balance things. The balancer works to do that. The reason why, like, all of these things are you talking about these ones being 1, or this one here being 1, which I said?
Yeah, the left side one.
Yeah, that was just all that I was doing was like giving an example of like some kind of change to the cluster. Like maybe you replaced that disk with a larger one. That was the purpose of that. These are all, this crush weight on the left is the size of the disk in terabytes. So I was like, on this cluster, like they really are 500 gigabyte disks connected. They're just small this is a small VM. And I was just like pretending that I had replaced it with a 1 terabyte disk. That's what I did for the demo.
Yeah, because I have mixed of cluster. I have 6-7 clusters. So
yeah,
2 clusters are old and they are mixed with different size drives. That's why I keep doing balancing by changing the weight of the on those. But on rest of the cluster, I never changed the weight, and it balances everything automatically.
Yeah, you shouldn't like you don't need to change the weights, like neither this weight nor this weight. You shouldn't be changing those to balance the cluster. You should just configure the balancer, like Ceph balancer on, like check Ceph balancer status. Make sure that it's like on, make sure the mode is upmap, and it will like make things quite even. And also this configuration I said earlier about where is it, the Ceph config, like this setting here is very important to make them like very tightly balanced. So like Ceph config set MGR this value and 1. Yeah, this is important. This is what you need to make it balanced. Yeah.
So